Hi everyone. We'll be starting with the last track now in a couple of minutes. So if you want to just sit down or take a place, that'd be nice. And so I'm also gonna introduce. Sorry. We are having some technical problems. So now we're going to start with the interoperability track, and we're going to have as a host Alessandro Ricotone. He's the head of research at LISC, and yeah, he's going to walk us through everything with interoperability. And yeah, so I'll leave you with that.
Thank you, Santiago. Hello, everyone. I'm Alessandro. Thanks. Thank you. I'm the researcher at LISC, and I'm very happy to be here hosting the interoperability track. You know, the last track was super cool. We had, this impromptu DJ set as well. Now it's a bit time for the nerds, if you want. And, interoperability is something very important. In general, it's just the capability of different systems to exchange data, exchange information. And if you think about it, interoperability is something that we are very used to. Us as human beings are interoperable with each other, right? When we talk computers, internet is interoperable. And this is especially important for decentralized systems and blockchains in particular. And indeed, if you look at the current state of the industry, we have several layer one solutions that differ from each other. But in this sense, it's very important that users are able to move assets, tokens, and so on between these different layer one solutions. And indeed, interoperability is something that several teams have been researching and implementing in recent times. But there are still a lot of important open questions. For instance, what are the security and technical challenges that come with interoperability? How will interoperability look like from the user perspective? And since this is blockchain in use after all, which new business cases will be built on top of interoperability? And hopefully to answer some of these questions, we will have three presenters today. And then finally, we will conclude with a panel discussion. So without further ado, I will introduce our first speaker for the keynote presentation, Patrick Sibetz. Patrick has a past in mathematics, in financial math, and then decided to jump the fence and start working for blockchains. In particular, now is community manager for the Swiss, German, and Austrian region for Algorand Foundation. So please welcome to the stage, Patrick.
Thanks, Alessandro. Hello from my side. I'm really happy to be here as well, even if it was on very short notice, but I have now the honor to kick off the interoperability track with you, and I hope the short break was enough for you to refresh, because I know there was a lot of intense and informative talks already, and I tried my best to give an informative and entertaining talk about a really, really important topic as well. And I hope you get a message from that as well with you. So, I'm Patrick, as already from Alessandro. I worked in equity trading and I jumped ship now, working full-time in blockchain, as I think, as well as many of you, that this is really the future. I'm responsible for the German-speaking region for Algorand, and you can find us or follow us on Twitter under the handle of DACH, where there's also in our bio the link to our Discord, where you get all other links and information I might refer to on later, and you can communicate with us and of course share your ideas if you want to be part of our community. And if you already have some certain plans or want to discuss in person with me, please feel free to use my Telegram and ask for a meeting. So, as Alessandro has pointed out, I think we can all agree on that collaboration, building bridges, not only in digital world, also in real life, has benefit for most of the users. So I think throughout the history we have seen, if someone isolates himself, be it nation state, cities or so on, they will not make it in the long run. So collaboration, building bridges, letting people, goods move throughout the ecosystems is a key aspect of prosperity and advancing as a society. And But I think you all know that this, of course, comes with the problem of this only works nice on paper or in theory, as long as we have honest players, as long as we have security and frictionless movement between these different worlds. And the same applies, of course, for blockchain. If we experienced over the last years the same desire and needs from people saying, okay, we have a fragmented ecospace, different blockchains building different solutions, and you find yourself saying, okay, I like this blockchain, but other use cases and programs or solutions on other blockchains are nice and I want to move in between there. This has caused the urge and the need for these so-called blockchain bridges. And I mean, compared to the in real life bridges, when we talk about blockchain bridges, we are saying, okay, we want to move digital assets or information from one protocol to the other. And the building of these, in theory, bridge has brought the solution, what we know, these so-called centralized bridges. So this first iteration of this technical implementation of bridges in the blockchain world has, as we all know, led to a lot of exploits, losing millions of euros due to these hacker attacks and so on and so forth. That's why I call it the first iteration. I don't think we can stop here if we really want to advance in the blockchain space. So what was the problem here? If we go through a classical use case in want to participate in one of these blockchain bridges, is saying, okay, Alice want to send 10 Alice coins from blockchain A to her friend Bob on blockchain B. How does this world work? And how are the solutions in place in the current state where we say this centralized bridge solution? So normally you see this in a chain of smart contracts which act as some sort of vaults and lock boxes. So Alice needs to make sure she sends her Alice coins to this bridge smart contract. They are being locked there. The bridge solution then mints an equivalent of a wrapped Alice coin on blockchain B, and once it's verified that the actual Alice coins on blockchain A are really there and locked, those are being freed and sent to Bob. This all sounds nice and on paper, but as you know that these solutions have been built by these third-party solutions, where normally this is like really a one-stop shop saying it's needed what we have desired, so it's not decentralized anymore, it's really one party, you entrust your whole flow of goods or assets. And as, of course, if bridges become more and more important, what we have noticed is that also the value accumulates, and it's not actually the goods traveling on the bridge, as I said, they are locked in a smart contract. Of course, having this one single counterparty and increasing value due to the desire of moving goods, the smart contracts have become a really, really desirable attack surface. And yeah, this has led to these exploits. So the thing is, people were suggesting, okay, then we just decentralize these third-party solutions. At the end of the day, you still expose yourself to a third party. Okay, the one player might not be a bad actor, or you can get rid of bad actors by saying it's decentralized. If one of the bridge solution architects or participants in this consensus is, as I said, a bad actor, you can get rid of that. Still, you have the problem of having your moving assets exposed to a third party. So, of course, every one of us is asking the same question. Normally, we would assume the other blockchain directly asks the questions, or they communicate with each other. But as we all know, natively, they cannot communicate with each other. So how can we go from here? So Algorand has brought up a solution most recently, so it's since last week on mainnet. You can see also the open source code on GitHub, which are called Algorand State Proofs. This is really an infrastructure solution which allows you from outside the Algorand network to have some sort of information snapshot. You can check for account balances, transactions, state of smart contracts, and so on and so forth. Sounds nice in theory, but how does this actually work? So conceptually, this is really a short letter summarizing the most recent transactions, all of the people or consensus participants who have signed these transactions by the network itself, and this gives you like some sort of common agreed standard that this has happened and you can trust them. Why can you trust them? Because it's basically, so looking under the hood, it's a compressed set of signatures from these consensus participants to a statement or event. You can see this like light block header from a certain block. This means that the whole consensus participants take the information from the most recent past, wrap it, sign it, and send it to the network. The network then accumulates, gathers all these signatures, and then compresses it into a state proof. And this is then being sent to the outside world who has the required setup to make use of that. So when I talk about, okay, we have the state proof now, how can you make use of it? That's where we would suggest this setup of some sort of light clients, because we all know if you live on Ethereum and you want to look into the Algorand blockchain, it's, by the computational effort, it's not even close to possible to say, okay, you run an Algorand node and validate everything from scratch. So that's why we say, okay, every proof of stake blockchain who has smart contracts can build a so-called light client. And the light client is nothing more, you can see it as an oracle who has some certain domain knowledge of the, for the Algorand protocol and all what's going on there. So you can ask them if you set up this light client, which there is also a POC code on GitHub, on our GitHub rep. The oracle or this light client can then answer, okay, this is fine, and Alice has already deposited these 10 Alice coins in this bridge smart contract. And then within your smart contract on your chain, you can trust this state proof without the use then of this intermediary. So we got rid of this. Of course, you need to implement these light clients, but as I said, these are really light, meaning it's a really, really low computational effort, which can even run on smart contracts on most of the chains. Coming back to the original problem, how would this then look like using the state proofs, getting rid of these intermediaries, where we said, okay, these bridges, third-party contractors, how can the blockchains then natively communicate using this light client setup? The first steps are pretty much the same. So Alice needs to send her 10 Alice coins to this escrow account, to this bridge smart contract. Then the consensus, the protocol itself, wraps all the recent history into this state proof, and this is being sent to light clients. Now we know that other blockchains do not have the capabilities of handling the state proof, even though this is already a really tiny piece of data. Our head of cryptography, Chris Pikett, and his team has worked over the last year to get this in an even more compressed and quantum secure. I'm not moving on. Sorry, it's such an complicated topic. And Alessandro was asking me about if I go into quantum security and these CK SNAC proofs. As I said, everything is there on our Discord, and I highly recommend you to watch his YouTube, where he goes into more detail about these CK SNAC proofs and why this is so elegant and so secure, and you can trust this short piece of message to being automatically sent to this light client, and you don't need this. And that's why we say this is really the setup you can go for to remove this. And of course, the state proof technology is open source, so every other blockchain can really easily use this. I'll skip that. As I said, this post-quantum security, trustless bridges, I think what we need to go for to get rid of these intermediaries, and that of course also these oracles can use this on-chain data in a really elegant way without the use of an intermediary. And we at Algorand, we really think that you can make a good solution and set up a really, really nice solution for many, many use cases. But what is for sure not the case is that you be the best in class for every requirement in the blockchain ecosystem. And that's why we think that the future is multi-chain. And what we need to work on is lay the foundation for a really, really good technology to move within the blockchains in a frictionless, nice, and cheap way. And let's build this future together. Thank you very much.
I still have a question on your talk. So you mentioned that in order to participate in these light client protocol, chains have to have a proof of stake consensus algorithm. I guess, correct me if I'm wrong, but your solution reminds me, for instance, of other solutions like Cosmos, where the requirement is actually finality. Is that correct?
Yeah, that's correct. So for proof of stake, it's of course required to do something like that. Why? Because for proof of work, you just look at the latest block, look at the headers, and everything is fine because has been done by work. A proof of stake, you have a different problem, which is like a feedback loop saying, okay, you always come back to the source. You see that this and that account has approved for the latest transactions. But then you don't even know if the account balances of the validators is correct. So you have to go back to basically the Genesis block and check through every transaction if the account balances are right, and then if they can actually approve. So you have to do everything from scratch, and that's why we said, okay, for proof of stake, to check other and trust other blockchain protocols, we need to come up with something new, and that's one really nice initiative we think is the case.
Thank you. Thanks again. Applause.